Good morning and welcome back to my YouTube channel. It's a bright and sunny day in Nairobi City in Kenya today, and I'm glad to be taking you through Lab 7 of HCAI Datacom on creating an IPv6 network. About this lab, Internet Protocol version 6, commonly just referred to as IPv6, is also called IPNG. IP next generation, that's very important. IPNG. It was designed by the Internet Engineering Task Force, IETF, and it's an upgraded version of IPv4. IPv6 have the following advantages. Number one, infinite address space, hierarchical address structure, plug and play, simplified packet header, security, mobility, and enhanced quality of service features. So in case you don't understand any of these advantages, please watch my theory video on IPv6. So this chapter describes how to set up an IPv6 network to help you understand the basic principles and address configuration of IPv6. Objectives: you are going to learn how to configure static IPv6 address. You're also going to learn how to configure a DHCP server, how to configure stateless address, also called SLAC, how to configure static IPv6 routes, how to configure the route, and also how to view IPv6 information. So the network topology, an enterprise needs to deploy IPv6 on its network. So we have 3 routers in our topology. We're supposed to configure static IPv6 address for the interfaces on R2. So R2 is here. So this interface here and this one here, we are supposed to configure them with static IP addresses. Then we need to configure stateless address auto configuration on G003 on R1. So this interface here, we are supposed to configure stateless address, so SLAC. Then we need to configure an IPv6 address using DHCP on the interface G003 on R3, this one here. So I have changed my my topology a little bit, especially in terms of the interfaces I've used. Instead of using G003 between R1 and R2, I've used G000. And instead of using G004 and G003 between R2 and R3, I've used G001. So it is important that at this point I mention that you need to use the router AR2220. Earlier when I was trying out this lab, I used the router with the name router, this one here. Unfortunately, it does not support the DHCP IPv6 DHCP command. So that's why I had to change to AR2220. So make sure you do that. So I've just labeled my topology to say that here we are going to be using SLAC to assign this interface and address. Here we're going to use DHCP. Then here we're going to configure static global address. So 2000 is a global range /64. Similarly, on this interface on R2, we are going to use static IPv6 address using that global unique address, IPv6 address. Okay, so let's go on. Let's go on and see how to do this. So we're going to configure static, then DHCP, then stateless, then IPv6. We display the IPv6 address. So step number one, we need to name the devices. I haven't done that, so we're going to do it. After that, on step number 2, we are supposed to enable IPv6 globally. So the IPv6 command enables the device to forward IPv6 unicast packets, including sending and receiving local IPv6 packets. So if you try to configure IPv6 and you've not enabled it on the global, then it's not going to allow you to do that. So we need to do that. And then on the other hand, we're also supposed to use the command IPv6 enable on the interface view, so this command, in order to enable IPv6 on the particular interfaces that we are going to use. So let's do step number 1 and step number 2, and then we can proceed from there. Okay, so here we want to name this device sysname R1. Then we go to the next device and do terminal monitor so that we don't get the feedback. We go to system view, then sysname R2. Then we go to R3 UTM, system view, then system name R3, enter like that. Then you can go back here and begin enabling IPv6 by using the command IPv6 just like that. Then we go to R2 IPv6 just like that. Then we go to R3 IPv6 like that. So after we've done that, we now need to enable IPv6 on all the interfaces that will be dealing with IPv6. So on R1 it is G00 G0/0/0. So here, if I try to do IPv6, for example, address, let me see, IPv6. So you see, I can't even do IPv6 address because I have not enabled. So I have to enable IPv6 in order for me to be able to configure an IPv6 address. So you can see really that you have to use the enable command first in order for you to be able to configure IPv6. Okay, so we go to R2. As you can see on the background there, on R2 we have G000 and G001. So int G0/0/0 IPv6 en for enable. Then we can go into interface G001 IPv6 enable, just like that. Then we can now go on to the last router here, int G0/0/1 IPv6 enable, like that. So we are done with step number 1 and step number 2. We can now go to step number 3. In step number 3, we want to configure link local address for the interface and test the configuration for the interfaces and test the configuration. Now, maybe just as a reminder, in IPv6 we have IPv6 address types. So really, in IPv6 we have what we call unicast. Let me say number 1, for example, we have unicast addresses. So on unicast addresses we have the global unique addresses. Normally they begin with 001, so they'll have something like 2000 like that, then slash something. Then we have after that we have the link local. So the global unique IPv6 address is just like the public IPv4 address, and therefore they can be routed on the internet. Then we have link local. Link local normally is the address that is used when when that particular device has not been assigned a particular IP address. For example, in IPv4, if you use the ipconfig command on command prompt, if a device has not been assigned an IP address, they normally have a link local address, which is 169 then something. I can't remember the full address. So link local plays the same role, but link local is not routable, so it can only be used on the layer 2 network. If a router receives a packet whose source address is a link local address, it's just gonna discard it. It's not going to forward it beyond that network. So link local is only used within a layer 2 network. Normally they begin with FE00, then slash something. Then we have the last one, which is unique local address. This one is the private IPv4 address, similar to that. That is, so with the unique local, it normally starts with FD like that, slash something. I can't remember very well. Otherwise, other than that, we have multicast. We have multicast addresses. Multicast addresses normally begin with FF like that, slash something there, and lastly we have anycast. We have anycast. So while unicast addresses can only be assigned on one interface, anycast address, the same address can be assigned to multiple interfaces, and you'll be routed to the interface that is closest to you, because the routers are going to use the IGPs to calculate the cost and find the shortest path to the closest interface that you are. So that is what anycast is used for. Multicast, of course, is a group, so can be assigned to multiple interfaces. If you join that group, then you can be able to process that multicast packet. So those are the address types. So now we want to configure. What we want to configure now is a link local address. Good thing, or another thing I want to mention about IPv6 addresses is that IPv6 addresses can be assigned, more than one type or more than one address can be assigned to the same interface. So we're going to see that we are going to configure several types of addresses on the same link. Okay, so let's move on. So to configure an interface to automatically generate a link local address, so that's what we want. We need to use the command IPv6 address auto link local. So this will enable the generation of a link local address for that particular interface. Now, it is important to note that only one link local address can be configured on each interface, only a single one. Again, to prevent link local address conflict, automatically generated link local addresses are recommended so that you don't configure manually. So that's why we are using the command auto. After an IPv6 global unicast address is configured for an interface, a link local address will automatically be generated anytime you configure an IPv6 global unicast. And then a link local address will also be automatically generated. Okay, so let's move on. Let's move on and configure the link local addresses on each of the IPv6 interface. Okay, so here, okay, create UTM, system view. So here we want to go to int g 0/0/0. Then we use the command IPv6 link. Okay, let me confirm that address. Okay, address auto link local, like that. So that is the command. Enter, then quit. So if we do display IPv6 int g 0/0/0, it should have a link local address. So you can see it begins with FE. So this is the link local address of that particular interface. Command to view that or confirm is that one. Okay, so let's move on to this one. System view. Okay. I like the background to be that so that you can see the interface that you're configuring. So we can even do display IPv6 just to view whether it already has a link local address int G0/0/0. So no IPv6 address exists on the specified interface. So you can see that's the information we're getting. So let's generate a link local. We go to that interface 00. We use the command IPv6 address auto link local. So just like that. And now if we go back using the history command and do display that, you can see that it has a link local address FE. Okay, so let's do the same for the next interface there, int G001. Again, IPv6 address auto link local. Enter. Okay. So we are done with that. We can go ahead and do the same on R3. System view. Interface G001, as you can see on the background there. Then we use the command IPv6 address auto link local. Enter. Okay. So after that, we can just test that we are able to ping. For example, we can ping from R3. We ping G001. G001 is on. Oh, okay. Okay. So display IPv6 interface G001 like that. So this is the address of G001. We want to ping it from R3. So let's do that. To do that, the command to do that is this one: ping IPv6, then the address you want to ping, then -I, then you specify the interface from which you are pinging from. -I. So you have to use the -I option. Okay. So here we want to ping this interface G001 on R2 from G001 on R3. So to do that, we do ping IPv6, ping IPv6. We can paste that, then -I, then G0/0/1 like that. So you can see that indeed we are able to ping that particular IPv6 address. Otherwise, if we try, for example, to ping display IPv6 interface G0/0/0. If we copy this link local address for that interface and we try to ping it, what happens? Let's see. So ping IPv6, we paste it there, and then -I from G001. So you can see that the request is timing out because we cannot be able to ping G00/2 because with a link local address, it cannot be forwarded beyond the network, beyond layer 2. Cannot be forwarded by a layer 3 device. So that's why the request is timing out. Otherwise, we can be able to ping it from R1. We can be able to ping G000/2 from R1. So let's do that to confirm that it's working. So how to do it again is ping IPv6. Then you paste that address, then -I. Then we want to ping it from G000 of R1, like that. So you can see that we are able to ping G000 of R2. So we can indeed confidently say that the link local addresses are working. Okay, so let me just point this out. It's important that when you ping a link local address, you must specify the source interface or the source IPv6 address. So it is a must that you do it. So always remember to do it. Okay. Okay. Let's now look at step number 4. In step number 4, we want to configure the static addresses. The static addresses of R2 over 2. So the command to do that is you go to the interface and you use the command IPv6 address. Then you enter the shortened IPv6 address and what do we call it? And the length and the address length. So the address length here is 64. So let me just copy this. So we're supposed to configure G000 and G001 for our case. Okay, so G001 is supposed to have 23. This one is supposed to have 12. The rest is the same. Okay, so let's do that. So on R2, we are configuring static addresses. So we go into int G0/0/0. Then we use that command IPv6 address 2000 because it's a public. As you can see on the background, 002:264. Then we go into int G0/0/1. As you can see on the background, the address 23.200:0023:264. Okay. So you can always use the command display IPv6 int brief to see the interfaces that you've configured with IPv6. So you can indeed see that we have configured this interface. Okay. You can see that we've configured G000 with this IPv6 address. So the physical status is up, the protocol is up. Again, we have configured G001. So physical status, protocol status up with this IPv6 global unicast address. Okay. So that's how you check. Again, the command is display IPv6 int brief. Okay. So let's move on to the next step, which is step number 5. So step number 5, we want to configure dhcp v6 server function on R2, then configure R3 to obtain IPv6 addresses through dhcp version 6. So we want to configure the dhcp server function. Okay. So to do that, just like in DHCP version 4, we need to begin by enabling DHCP. So using the command DHCP enable, then we create a DHCP v6 pool. We are calling it pool 1 in this case. Then we give it the address prefix. So this is a global address prefix. So 23::/64. So address prefix, and then we also give it the DNS server address. Then after that we can quit. Then we go into that particular interface G001 for us. Then we use the command dhcp v6 server pool 1. So let's do exactly that. Let me copy this. Okay. Okay. So you begin by doing dhcp enable, then dhcp v6 pool, Then we are calling it pool 1. So that's the name of the pool. Then here we want to do address prefix. So the address prefix is supposed to be 2000 colon 0023 colon colon slash 64, like that. So that is the address prefix. Then the DNS server is at 2000 colon 0023 colon colon 2, like that. So after we've done that, we can get out of the pool. So in DHCP v6, we really don't have to specify. We really don't have to specify the gateway address. Okay, so now we can go into the interface G001 on R2 and use the command dhcp v6 dhcp v6 server question mark. The next thing is the pool name. As you can see, dhcp v6 pool name. So we want this interface to use pool 1 to assign DHCP or IPv6 addresses and the DNS server address. So that's all we have to do on R2. So let's see what we're supposed to do now on the client, which is R3. So we need to begin by enabling DHCP using the command dhcp enable. Then we go into the interface G003 and use the command IPv6 address auto dhcp. Then after that, we can use the command display IPv6 interface brief in order to see whether we've been assigned an IP address. Okay, so let's do exactly that. If possible, we can even do a data capture so that you can just appreciate. Start data capture. Okay, so I've just done the data capture so that you can see the DORA, the DHCP DORA. Okay, so the command is dhcp enable. Then we need to go to int G001. Then IPv6 address auto dhcp d. So you see it can either be global or link local or DHCP. So we want DHCP. Enter. So after we've done that, you can see indeed that we are having a DORA taking place, and we are having the neighbor solicitation and neighbor advertisement packets being exchanged between the DHCP server and the DHCP client. So you can see the DORA solicit, advertise, so then request, then reply. Okay, so let's go ahead now and see. Let's go ahead now and see that particular address. We haven't quit. So display IPv6 int brief. So you can see that indeed, this interface G001 physical status is up, protocol is up, and it has been assigned the IPv6 address 2000:23::1. So it has been assigned that particular public address. So that is all we needed to do in this particular step. Now, the DHCP server does not allocate an IPv6 gateway address to a client. It does not do that. So when the DHCP stateful mode is configured, IPv6 clients learn the default route of the IPv6 gateway using the IPv6 address auto global default command. So that's why we don't need to allocate the IPv6 address. So when the DHCP v6 stateless, so this is when stateful is used. When stateless mode is used, DHCP clients learn the global unicast IPv6 address and the default route to the IPv6 gateway through this command. So ensure that the interface of the peer device connected to the local device has been enabled to send router advertisement packets using the command undo IPv6 nd RA halt command. So configure DHCP server to allocate the gateway address to clients. To do that, we go into the interface and we use the command undo IPv6 nd RA halt. But we already saw from the packet capture that we received the array packets. So let's just do it. Undo IPv6 nd RA halt is the command to do that. Here we get into interface G0/0/1, then undo IPv6 nd RA halt, like that. So this command enables the system to send router advertisement packets. By default, router interfaces do not send router advertisement packets. Then we have another command, IPv6 nd autoconfig managed address flag. We know that we have the managed the M flag, normally called the M flag, which is the managed flag in router advertisement messages. This one, it indicates whether the host should use stateful auto configuration to obtain addresses. So when the value of the M flag is 1, it means use stateful. When it's 0, it means use stateless address auto configuration. So that is the M flag. So by default, the flag is not set. It means that by default the flag is 0, really. We actually closed that that data capture. I'm not sure whether it's still sending router advertisements. Okay, let me see if I can go to int G0/0/1. Display this. Undo IPv6 address auto dhcp. Okay, so then I can do it again. IPv6 address auto dhcp, like that. Okay, so let's see whether we have a router advertisement RA. Do we have an RA? DHCP v6 SCMP neighbor advertisement, neighbor solicitation. No, we don't have a router. We don't have it, a router advertisement. Okay, I wanted to show you the M flag of the array, but it's not there so far. So let's continue. So we can use this command. Let's copy this command in order to enable the array on R2. So let's just enable it and see whether it's going to be sending that. So if the M flag is not set, a host uses stateless auto configuration to obtain an address. That is, the host generates an IPv6 address based on the prefix information in the array packet. Okay. By the way, let me just confirm. Let me confirm whether this display IPv6 interface brief. Oh, ooh, we don't have a. We no longer have a. How come? Okay, we no longer have a public IP address. This is the link local FE, but we need the public address. I'm not sure why it declined. I'm not sure why it declined. I think we requested to use a particular address and it declined. The server declined. dhcp v6. Okay. We're using the link local as the source. Oh, we have a route advertisement here. Okay. So we've received a route advertisement. So let's see whether we have the address now. Not yet. Okay. Okay. So on the route advertisement packet, let's see the M flag. Where do we have it? Router advertisement flags, they're here. So you can see that the first one is the managed address configuration. This is the M flag, the first bit here. So when it's 0, it means it's not set. When it's not set, it means you have to use stateless address configuration to be able to generate an address from the prefix that we've shared with you. So that is the managed flag. The other one is the O flag, the other configuration, which we're also going to talk about shortly. Okay. In the meantime, excuse me. Let's go into int g001 and do display this. Display this. Do we have? We have it. It's already on that. I'm just wondering why we have not received an IPv6 address. Global address. Okay. Display IPv6 interface brief. We still don't have it. Okay. Let's just continue, and then we will see how to get around that in a short while. So for now, let's configure the M flag by using that command so that we can enable it. To enable it, we need to go to the interface here. Interface G001. Then the command I had copied it is IPv6 ND autoconfig manage address flag. So if we do that, then here, if we receive any other router advertisement, the managed address configuration flag here will not be a 0 but a 1. It will be a 1 going forward. Okay, so we will have a look at that. The other one is the IPv6 ND autoconfig other flag. So let me copy this command again. So this command is used to set the other flag. Now, the O flag, if the O flag is set, a host uses stateful auto configuration to obtain other configuration parameters. So other configuration parameters are like the router lifetime, the neighbor reachable time, retransmission time, maximum transmit unit, etc., etc. So that is what we call the other. Otherwise, if this flag is cleared, a host can obtain configuration, that is the IPv6, such as the router lifetime, neighbor reachable, retransmission, and the PMTU in stateless auto configuration. So this means that a routing device advertises this configuration using messages to the attached hosts. So that's how we do it. Okay, so let's use that command on that same interface. So we can just paste it there, autoconfig like that. Then after we do that, I think now this is where configure the client to learn the default route through RA messages. So to do that, we need to use the command IPv6 address auto global default. So that is why we had not, that's why in the dhcp-v6 you don't configure really the gateway, because you're going to configure this. So we are supposed to configure this on R3. So let's do that. On R3, we go to interface G0/1, then IPv6 address auto global default like that. Okay. Then we can use the command display IPv6 routing table to view this global default global route if it has been added to this particular routing table. So let's have a look at that. On R3, we use the command display IPv6 routing table. Enter. So we can see that the next stop is this, which is the link local address. This should be the link local address AB6. Should be the link local address display IPv6 int brief. Display IPv6 interface G0/0/1. So AB6. So it is the next stop is the link local address. So this is the default gateway for this particular router. And for any destination, send it to this next stop. Outgoing interface, this one, G0/1. So that is the default that we've just created, the default route that we have just created. Okay, so let's now configure R1 to obtain an IPv6 address in stateless mode. R1 to obtain an IPv6 address in stateless mode. Okay, so to do that, we need to enable RA on G00 on G000 of R2. So to do that, we use the command again, undo IPv6 ND RA halt in order to enable RA. Then after that, we need to enable stateless address auto configuration on G000 of R1 using the command IPv6 address auto global. So let's do exactly that. So here on R2, we go to int G0 stroke 0 stroke 0 stroke 0, which is the one that is connecting to R1. Then we use the command that. Then on R1, we go into the interface G0 stroke 0 stroke 0. Then we use the command IPv6 address auto global, like that. So once we do that, we can view the IPv6 address by using the command IPv6 interface brief, like that. Display IPv6 interface brief. So we can see that we've been given the prefix. And we have been able to auto-generate a global IPv6 address. Okay. Now the next thing we need to do is to configure. So you can see that G000 over 1 generates an IPv6 global unicast address based on the IPv6 address prefix obtained from the RA message sent by R2 and the locally generated interface ID. So it uses that prefix and the link local ID. Okay, step number 7. So here we are supposed to configure a static route from R1 to R3 in order to enable connectivity between them. So to configure the static route, we use the command IPv6 route static, then the destination address and the length, then the source. So that is the command. That is the command that we are supposed to use. Okay. So IPv6 route static, like that, and then 2000 colon 23 colon space 64, then 2000 colon 12 colon oh, this is the next hop now. This is the next hop. Yeah, this is the next hop, and this is the destination. The destination network address. Destination network address and the length, then the next hop. So if you want to go here, send the packet here. So that is what we are doing here. Actually, what we want to do is to enable R1 to be able to communicate with R3. So that's what we want to do, to be able to ping R3. So that is why we are creating this static route. Okay. So once we do that, once you configure that static route, then we can be able to ping. We can be able to ping R3. So we can be able to ping IPv6 2000 23 colon 1. Oh. Okay, I understand. The problem is our interface lost the IPv6 our interface on here lost the address. So let me try and see if we can, for example, int g0 stroke 0 stroke 0 stroke 1 display this. Let me copy these commands, copy, then I disable IPv6, IPv6 enable, display this. Okay, good. So I have disabled IPv6, so let me enable it, IPv6 enable, then I can paste those commands. So I hope now it receives a global address, display IPv6 int brief. Good. So it has received an IPv6 address, global IPv6 address, colon 3. So we need to ping now. We need to ping colon 3 instead of colon 1. So 3. Okay. So you can see we are able to ping it. We are able to ping R3, whose address is 2000 colon 23 colon 3 colon 3. Okay. So what else are we left with here? Okay, so of course R3 will obtain the default route through dhcp v6. So we already said that. We can also use the command display IPv6 neighbor in order to see the neighbor information. So that's the last thing we'll be doing. So here we use the command display IPv6 neighbor. So we can see that we have this neighbor. And we also have this neighbor AB5. If we come here and do display IPv6 int G0 stroke 0 stroke 0, so you can see that the link local address of this is AB5 of G000 of R2. So we have a neighbor relationship with that link local address and also a neighbor relationship with this global public unique address, global unique IPv6 address. And as you can see, the same addresses are, both addresses are on the same interface. So just as I mentioned earlier, that in IPv6 you can configure more than one type of IPv6 address on the same interface. So this interface G000 on R2 has a link local address. It also has a global address. So ladies and gentlemen, thank you very much for your time. I'm hoping that you've learned something. Make sure to watch the theory topic if you hadn't done so that you can understand better the principles of IPv6. Otherwise, thank you very much for your time. Remember to like my video if you learned something, share it with your colleagues, and also subscribe. Asanteni sana and God bless you. Bye bye.